Hi, you are most welcome to our class day 2. So today we shall talk about the network reference model. Yes, we needed that model. We started with the OSI, Open Systems Interconnection. It was the very first one. So it is still theoretical, but we shall find out more. Let's go to slide 2. So in the digital era, various information is presented as data in our lives. But what's data? How data is transmitted? So in this course, we shall cover the network reference model to understand how real data works. They are calling it life of data. So our objectives for this second class is to understand data definition, transmission process, concepts, and advantages of network reference model, the common standard protocols used, and how encapsulation and decapsulation works. So straight away, let's go to applications and data. So the applications you see that you use on your phones, they generate data true, but do they also transmit that data? I think that's the question you should be having as you go on with this class. They do generate data true, but what happens during transmission? Is that role played by an application? That's the question you should be having on your mind. So data generation, the computer field data is the carrier of all kinds of information generated by most applications is to be transmitted between devices. So what happens if from this structure, from this diagram here, you can see that we're having data being generated by these different devices, the server, the desktop computer, the laptop, and this tab here, our phone. But I think that in here, in between here, it is network that does all of that. Yes? Okay. So from that picture, it can really show that the application, it can't really work on the transmission. So I've answered the question, yes? Yes. So let's go to now network reference model and standard protocols. So network reference, the OSI reference model, as I told you, the open system interconnection, we have seven main parts, seven parts. We have application layer, presentation layer, session layer, transport layer, network layer, data link layer, then finally physical layer. So all these different layers, each has a role to play in here. So for the application layer, it just provides the interfaces, users, it's general for users at the, normally you want to develop an application, you're doing it for users. So just provides that interface. You get that's the application layer. In the presentation layer, it deals with the formatting of data. Because before data being transmitted, we have to format it in a certain way before transmission. So session, it manages and terminates session between communicating parties. Now, an example I can give for session, if you are sending a message and it's incomplete, and then when you turn on the phone and you're back online, so the layer that is responsible for us not to go back to the initial process, like to just start from where it has ended, the whatever you're doing, that layer, it's the session that does that. Yes. Yeah, it will. Oh, I transmitted that done a lot. Done if it's like let's look at like at a book. I transmitted like 14 pages. Now I'm starting from page 15. So that's the section that does that. Now transport layer, it's for end-to-end connections. We shall get to know that. This is where you find the port numbers in most cases. So network layer now for it just provide logical addresses, the IP addresses you hear of from the destination or from the source to the destination. Then the data link layer, this one deals with encapsulating the path into frames. Yes, and it uses protocols like point to point, point to point. But some of the things we are mentioning in short forms, we shall find them out as we go on with our classes. So now the physical layer is when the transmission happens, bits, transmission, media, the electrical physical specification is. So that's, yeah, that is it. So as you go down from 7 to 1, that's what happens is called encapsulation. Then once you're moving from 1 to 7 upwards, that's the encapsulation. So what I said first 7 to 1, that happens at the sender side. Then at the receiver side, it will be 1 to 7 like that. You're decapsulating to get the real data that was sent by an application. Okay. Now from here, that one is that OHI protocol is complex, and TCP and IP protocols are widely used in the industry. Therefore, TCP/IP reference model becomes the mainstream reference model of the internet. Now, the OSI, it's still theoretical, and it just breaks, just tells you what's behind the generalized layers here. Because the standard one, we have application layer, meaning in there, the function that it has functionalities of application layer, presentation layer, session layer, all in one, the application layer. Now, host layer, that's the transport layer, host. Yes. The internet layer, network access layer. Under network access layer, you will find data link layer and the physical layer. But the equivalent one that we are using, that it's commonly taught, and TCP is the equivalent one. It has 5. That's not me, not this very well, who are web-based. That's the equivalent TCP/IP model. There are 5 layers. Yes. But in other books, you'll find there are 4, depending on the book you're reading, whether it's for Juniper, Cisco, or any other source. So take note of that. Okay. Now, what are the protocols we find in each layer? Now, for application layer, we shall find telnet. You shall find out what it does. For transfer protocol, what it does, you also find out. Trivial, for transfer protocol, TFTP. Then network management system, network management protocol. That SNMP. Yeah, that is just for remote access, managing different, like a lot of applications using SNMP. But you'll find out that I'll tell you an example from a practical view or from my own experience. And then we also have a hypertext transfer protocol, HTTP. Then we have that one, simple mail transfer protocol, DNS domain name system, DHCP. We shall find out all these in detail. Transport layer, we have TCP, UDP. Now for TCP, UDP one is connectionless, one is connector oriented. So then that is connectionless is UDP. It's one we use in real time. Those people who watch matches. The protocol used there is UDP. Like everything has to happen in real time. Once you miss it, Messi scoring a goal, yeah, you've missed him. Only that you're lucky that some of those things are recorded on YouTube, so you can easily go back. But yeah, during the live session is the protocol being used is UDP. Then TCP is that one is connection oriented. The network layer we shall find that the internet control message protocol, internet group management protocol, and the IP. Now, for internet group management protocol, where you will find the multicasting thing. Multicast, I mean, like you want certain to send the information to a certain group of users, just a group of users. Not all of them like broadcast does, but yeah, certain group multicast. So you find that in the IGMP, Internet Group Management Protocol. Now, data protocol, you have the point over Ethernet, point. You shall find out more about the protocols. And yeah, we're done with that slide. Let's move to the Common Protocol Standardization Organization. So we have the IETF, Internet Task Force, responsible for developing and promoting the internet protocol, especially protocol that constitutes TCP/IP protocol, because we told you, like the website is so theoretical for understanding what will happen is under the TCP/IP. Now we also have IEEE Institute of Electronic Engineers. Once you're in this class and you're not a member of IEEE, you should soon join, because I'm a professional member. I joined in 2018. Yeah, that's it. Now we also have ISO, the National Organization for Standardization. Yeah. So some of the things, yeah, I gave you a PDF to read in detail. This organization, if there's nothing much here, they can't say it. They can't ask you anything here that's much, unless you just have to know that we have this organization that exists. Don't think we just do these things don't take these things for granted, because normally why do we have this organization is for compatibility, that different companies are using different devices, but they can be able to communicate with each other. Yes, there are different devices, whether it's whether Huawei, the input, they should be compatible. So the organizations that help us do that or achieve that, they are the so-called standardization organizations that we have. So for now, take these 3. As you read more, you'll find out others in the other classes. Now, application layer, yeah, this now we are touching the numbers. For HTTP, it is 80, Telnet 23, FTP 20 and 21, SMTP 25, TFTP 69. Yes. Those are port numbers. There's nothing much there. So file transfer protocol, they're trying to show you what happens when we are using FTP, the file transfer protocol. So you have FTP client. If some of these things you shall achieve them during the practical, because remember I told you for these classes we shall have 15 days of theory and 15 days of practicals. So I won't say much here because I now will cover this practically during the practical sessions. For this class running for 1 month, take note of that. And the other protocol we have here, Telnet. Now we can see that we can also make use of Telnet, but through different devices like the AP, access point router, firewall. So we shall solve that practically. That's why I won't take much time on this. Protocol HTTP, we shall achieve that practically. I think I will use a firewall here, but yeah, don't worry, we shall achieve this practically. Transport layer now, as I told, this one is for end-to-end connection. TCP connected reliable protocol defined by EATF in RFC. RFC is request for comments, but it depends because when I was at work, we used to call this one request for change. So it depends on the environment where you're saying RFC. But with the IEEE, RFC means request for comments. Okay. Now TCP and UDP. Now these are detailed things how a header looks like for TCP and UDP. So you'll find that you have 20 bytes, UDP have 80 bytes. Other things in detail, please read through the document I sent you. Okay, TCP UDP port numbers, you should take note of those numbers. Though the other side, they will be random. It will be random. Both sides can't use those port numbers at the same time when communicating. Yeah, so they're showing you like under the header information in these protocols, you shall have that source IP, destination, source port number, destination port number, HTTP payload. That's the data you're sending, but using that protocol. Okay, this connection is set up through handshake. Now, what happens with three-way handshake? The first guy sends data, sends this information to the other guy is communicating to using the three-way handshake. The three-way handshake happens when you're setting up a connection before you. This is now happening at the transport layer. You want to send up the end-to-end connection before you transmit your data. So what happens is we shall have a source destination, and in the TCP header, we shall have the data sequence ascent. Acknowledgement is 0 because you have a good acknowledgement from anywhere. So now this piece one sends that to PC. Now piece two is like, okay, I've received A, send me A plus 1. So that's the arc you're seeing, A plus 1. But also this PC tags also synchronize. So it's sending its own sequence B. You can see that. You can see that here. It also now sends its own CYN synchronization bit. So now what happens? This guy sends, this guy responds to this message by sending the A plus 1. Then also to confirm I've received the bit, send me B plus 1 from that. So at the end of this three-way handshake, we have a TCP connection established. As simple as that. Now what happens after the TCP connection? Then we shall have communication going on. You're saying the payload being attached. I won't say much there. Now here TCP window sliding mechanism. Now what happens is the other piece tries to communicate like window, like how much can I receive? I can receive this. Okay, you've sent this, but I can receive this. Okay, send it to this amount. I can receive all of that. So window is like PC is able to communicate the size it can handle. And that's in the layman's language. Now for handshake happens during termination. Please the communication, by the way. Some people think, most people, by the way, what happens is when you're a student, you do the three handshake, and when you come here, you skip these notes. But now you see 4 handshake is for termination, but most students follow this question. So take note of that. It's 4 handshake, and use the information I explained to you with 3 handshake and relate it to the 4 handshake. Because trust me, you will be a good engineer or a greater instructor, better instructor than me once you learn to read on your own and understand. Anyway. But that is it relates to the 3 handshake knowledge I've just explained to the 4 handshake. Now, you just go to a network layer. Network is responsible for providing logical research for network devices, routes, and fast data packets. Common network level protocols include IPv4. The IPv4 was the very first one we We used back then we went to IPv6 after realizing that actually IPv4 is becoming depleted each and every day. As time goes on, people, you guys keep giving birth to kids, so the population keeps on increasing. So we realized that we need IPv6. So ICMP, I said that that's Internet Control Message Protocol, then the IGMP is Internet Group Management Protocol. Working process of network layer protocol. Now some of the things, I do them practically, you'll be seeing those port numbers, out-band interface when I'm in my NSP, when the time reaches. Data link layer provides inter-segment communication for network layer. This way, we do also have the physical addressing. Communication happens with physical addresses. So when I say physical address, take note of that. That's a meaning MAC address. You get. Yeah, but some of the things I was doing practical, we shall get to see that. I'll be seeing the MAC address, that's physical address. Then, yeah, some of the things you shall see them practically. Allow me go to the ARP address fusion protocol. Now, what happens is before communication has to go on, the source, the PC sending the information, the device has to get access to a physical address. The device, from the device, it's sending information to. So what happens is we use this protocol, we use its IP because the IP is normally logically addressed. We use its IP to find out the MAC address. So now here it's the guy will ask who has this IP. Wait. Yeah. So this guy knows the registration IP. Then he's asking for the MAC address. You get. Now this guy responds. Then this guy is able to communicate to piece what to be. You get. So if I now if so happens that this one is a one-on-one connection. Now if we have a switch, as I explained in the first class, a switch. Remember that a switch. Now this guy will broadcast the information to all the different guys asking who has this IP, so that it can get the MAC address of that IP. You get. Hope now that one makes sense. Because I'm comparing this slide to the first class we had. If you attended or if you have viewed the video that I shared. Yes, ARP implementation, we shall see this physical. Some of the things where you're seeing router devices, I'm going to talk about these things practically during the other 15 days. So physical based normally that where we shall have the final communication happening after going through the other 6 layers. Now the home transmission media we have the reset pair, RJ45 connector. You should be familiar with these things, especially those people who are hoping to be in the field. Move with the cars everywhere connecting for us internet. Data communication process. Now this is what I was telling you during encapsulation. This is what happens. You get, as you move from one data keeps on increasing. You get, like from here, from the application layer, you see that now you have a TCP data being attached, meaning here's the information. You get the port numbers and everything. So after now, this level, this one now, the whole of this becomes a payload. Then this one you attach an IP like that. Then vice versa. It's what happened at the receiver side. Yes, that some of the things. Yes. So you see that at the sender here we have all the layers here, but at the switch here it's only these ones are at practice, data link layer and physical layer. And once you go to the router, now this one here becomes this one here is a layer 2 device. You get data link layer, physical layer. Now the router is able has a bit of routing. That's why we have network layer. Then you go back to the other layers. This is where the decapsulation is happening. Encapsulation is happening here. But these 2 devices, they don't need this one. Only makes use of the first 2 layers coming from down. Then this one, the 3 layers coming from down. Yes. Summary before both reference model and TCP reference model adapt the layer design concept. Clear division of functional boundaries between layer facilitates the development, design, and troubleshooting of each component. The functions of which layer can be defined to impel industrial standardization, because as I've told you, the other layers are merged within the other TCP layer, the other layers of ASI. You get, interfaces can be provided to enable communication between hardware and software on various networks, improving capability. All right, data generation and transmission require collaboration between the modules. Meanwhile, each module must fulfill its own responsibilities. we have just explained that quiz. This food for thought for your own good. Answer to find out the answers to these two questions we have here. Otherwise, thank you for attending. Yeah, those ones who have attended, don't worry, there is a recording. There will be a recording for this class. Yeah, a lot of questions in my Telegram chat, in my inbox. Otherwise, I'm good. Hey, good night, guys. It's evening on my side. All right.